in this problem, which is opener number 2, we are trying to find how much fencing we need to enclose the area in terms of x. So a couple things to unpack. How much fencing implies that we need fences around all these areas, even below, and we want it in terms of x. So we know that x will be in our answer. Now, you might recognize that this is a perimeter problem, that you're trying to find how much on the outside you need. So to find that, let's zoom out a little bit. You need to be able to add up all these lengths, which are labeled in this diagram. So, this is a 3. So adding them up takes a little doing, and you might be tempted to write out, the whole thing and then figure out how to combine items, which is fine. So let's try that. So I'm going to take this left segment first, and I'm going to keep track of which ones I've already used so I don't have to keep reusing them accidentally. So 3x to the 4th plus 10x squared plus 1. And some of you might be looking at this like, do I really have to add all these up? Well, yeah, you do. You need to figure out this perimeter. And so I'm going to do it along with you. 3x squared plus 19. So now I've taken up that one and also this one. I'm going to now do this one by adding 3x to the 5th minus. Be really careful with your signs and your numbers. Take some focus, even though it seems like a tedious task. Now I'm going to add that one and that one, so I got 2 to add in now. Plus x plus 91 plus 10x cubed plus x squared plus 5x to the 1st, which is just 5x, but I wrote it to the 1st, so that's fine. You'll notice a measure in here, which is just really there to confuse you. It has nothing to do with the fencing you need, so I'm going to ignore it. And then looking at this taller segment, add in another x cubed plus 4x minus 8, and yet again add in that segment, which will give me another 3x to the 5th minus 4x to the 4th plus 3x, adding some more segments, 2 more left, plus, and I'll do it down here, plus 4x squared plus 6x plus 4x plus 6. So I added that in, and so now we have all the segments. Now one of the strategies is to try to combine like terms. So in order to figure out what like terms are, we need some scheme to figure out which ones go together. So I've noticed that I saw x to the 5th, so those were probably the highest term. But I think I saw a couple of them, so let's look at them. So I have a positive 3x to the 5th. I have another positive 3x to the 5th. So scanning along, any other x to the 5th? Nope. So now, looking for x to the 4th, I have positive 3x to the 4th there. I have negative 4x to the 4th there. I have another negative 4x to the 4th. And it's important to keep track of the negative sign as well, because it's easy to just add items without keeping track of whether they're negative or not. Any other x to the 4ths? I don't see any. Now, some of you might say, well, I'm not carrying around highlighters here, so what do I do to categorize? Some people use different ways of circling. So some people put a box around one, and then a circle, and then a triangle, and that helps them keep track. So that's another strategy. So now I'm doing my x to the 3rds. Scanning my lines, any other x to the 3rds. And the nice thing about this is once I've gotten everything, I can go back and see what's not highlighted and figure out what I missed. So now I have x to the 2nd, positive 10x to the 2nd, positive 3x to the 2nd, another positive 1x to the second, another 4x to the second. Any that I missed? No, alright, well, am I out of highlighter colors? It appears like I am. Let's see if I can get some other colors here. My highlighter. Purple, yellow, blue, green. What about like a red highlighter? So I'm going to highlight my x's, x to the firsts. Those are the same. One hiding there. Any other x to the firsts? Nope, and then looking what's left, it should just be x to the zeros or just constants, which is what it is. Great, so now I can start combining. So let's take a blue pen here, start combining. So I'm going to start with x to the fifths. 3x to the fifth plus 3x to the fifth is 6x to the fifth. Now working down to the x to the fourths, I have negative 4 and another negative 4 is negative 8 plus 3, negative 5, x to the fourth. Now my x to the thirds, which are in green, I have 10 and one more is 11, 11x to the third. X squareds now in yellow, 4 plus 10 is 14, plus 3, 17, plus one more, 18. X squared plus, now my x is in red, 4 plus 6 is 10, plus another 4, 14, plus 3, 17, plus 1, 18, plus 3, 21, 26 with the 5, and 30. Now that was a lot, and I didn't really use a good order, so I'm going to go back and count them in order going across. 4, 7, 8, 13, 17, 20, 26, 30. So sometimes you need to recount just to be sure. And I have one more, the constants to add. 1 plus 6 is 7, plus 19, 26. 26 plus 91 is 116, 117. Minus 8, 109. Plus 6, 115. I believe that is our polynomial to express how much fencing I need in terms of x.